Alright, in this video we're going to take a look at solving a 3x3 system of equations with no solutions. And as we mentioned in the intro video, that is when you have two planes that are parallel, or maybe all three planes are parallel, but you have at least two of them that are. These are the nice ones because using elementary row operations, we're eventually going to get on the left side of the vertical line a row of zeros, and then on the right side a number that's not zero. So much like with 2x2 systems of equations, these ones are going to stop you from continuing too far. So truth be told, these ones are, the no solutions and infinite number of solutions are the ones that most students want to have because truthfully they do require the least amount of work. So let's take a look and we'll see that we have one row is a multiple of another. We can do elementary row operations to write one row in terms of another, at least as far as the left side goes. So, all right, so our matrix, we have 1, 1, negative 2, 1, 1, negative 2, negative 1, negative 1, positive 2. So it might kind of look at these, might give you a hint right there. And then 2, negative 3, 2. Especially nice if you can find them while you're writing them. Sometimes that happens. 7, 3, and negative 2 for the right-hand side. That's a 7. All right. So again, just as before, we're going to start by making sure this number is 1, which is nice because it is. If it's not, we can maybe switch a row or divide and things like that. So now let's look at the values below it. This is a negative 1, so we take the opposite of negative 1 is positive 1 times this value and add it to this second row. So if we take row number 1 plus row number 2, or 1 times row number 1 and add it to row number 2, we can make that our new row number 2. And here we have a 2, so the opposite of that is negative 2. So if we take 1 times negative 2 and add it to this third row, that should make this a 0. So negative 2 times row number 1 plus row number 3, that's going to give us our new row number 3. All right, so let's see. Our first row is going to stay the same. But our second row, we're going to get row 1 plus row 2 and store that in row 2. So 1 plus negative 1 is 0. 1 plus negative 1 is 0. Negative 2 plus 2 is 0. And 7 plus 3 is 10. So we can actually stop right there. We actually don't need to do this negative 2 times row number 1 plus row number 3. So on the left-hand side, we have 0, 0, 0. That means 0x plus 0y plus 0z equals 10. So again, this row, this second row, indicates that 0 times x plus 0 times y plus 0 times z is going to equal 10. Well, as we know, we can't multiply 0 by anything and get anything but 0. So this is 0 plus 0 plus 0. And 0 equals 10. That is a false statement. So when we arrive at a false statement in algebra class, that means our answer is no solution. There is no solution to this system of equations. There's no value of x, y, and z that's going to make all three equations true at the same time. If we were to graph these three rows, we would notice that the first and second rows are in fact parallel. So if they're parallel, that means that those two planes are not going to intersect, which means all three planes will not intersect. So no solution. So again, look at how much less work there is in example 2a compared to like example 1a or example 1b. All right, example 2b. If we work this problem, let's see, we have 2, negative 1, negative 2, and then a 5. We have a 6, negative 3, negative 6, and a 10. We have a 5, a 0y, so we'll use a 0 for y, so there's an instance where we don't have a variable, and then a 4, and then negative 2. All right, well, again, we could get, we can get this equal to 1 by dividing everything in row number 1 by 2. So we take row number 1 and divide everything by 2, which is the same as multiplying by a half. Again, I'm not going to be too picky about that. We can make that our new row number 1. So let's see, we get 1, negative a half, negative 1, and 5 halves, or 2.5. 5 halves. All right, so row number 1 is the only one that changed. Again, we're not going to be spending too much time on this problem since it's going to be a no solution one. So that's what's nice about the no solutions and infinite solutions. You get stopped a lot sooner. All right, so if we take this 1, which is good, right below it we have a 6. So if we take, and opposite of 6 is negative 6, take row number 1 times negative 6 plus row number 2. So negative 6 times row number 1 plus row number 2. We can make that our new row number 2. And I already know what's going to happen, so I'm not going to bother with the negative 5 times row number 1, but you could if you wanted to. And add it to row number 3. But again, row number 1 is not going to change. It's okay about fractions. Sometimes we have fractions. That's fine. Fractions are very common. But negative 6 times 1 is negative 6. Negative 6 plus 6 is 0. Negative 6 times negative 1/2 is positive 3. Positive 3 minus 3 is 0. Negative 6 times negative 1 is positive 6. Positive 6 minus 6 is 0. And negative 6 times 5 halves is negative 15. Negative 15 plus 10 is negative 5. So again, notice we have to the left of the vertical bar a row of zeros. So this means 0x plus 0y plus 0z equals negative 5, which 0 is never going to equal negative 5. So because we have this row of zeros here on the left and a negative 5 on the right, that is going to mean we have no solution to this problem. There's no ordered triple that will make all 3 of these equations true at the same time. All right, that about does it for this video. In the next video, we'll take a look at infinite number of solutions where this number on the right-hand side of the row of zeros is 0. So again, you're not going to get as much work involved in these special case answers as we did in example 1A and 1B. So I will see you then.